This is introduced into the insertion handle from below. The connecting screw is inserted into the insertion handle and the attachment from the top, screwed into the proximal end of the intramedullary nail and tightened a little using the combination wrench. The unreamed tibial nail is introduced as far as possible by hand. Lateral positioning of the insertion handle facilitates the introduction of the intramedullary nail. In contrast to the situation in the clinic, a few light blows with the slotted hammer may be needed to insert the nail into the artificial bone. In this case, we need the inserter extractor for the UTN. It is screwed onto the proximal thread of the connecting screw. It serves to guide the slotted hammer during insertion and extraction of the implant. Having inserted the nail, the inserter extractor assembly is removed. If the nail is to be locked proximally, the insertion handle must be swung in a medial direction. The slot and groove of the insertion handle and the coupling block must connect properly. Proximal locking. The following instruments are needed for proximal locking: a protection sleeve, a trocar, a drill sleeve, a 3.2 mm drill bit, a depth gauge, and a screwdriver. There are two methods of locking in the coronal plane suitable for the unreamed tibial nail. If the bone length and its rotation have to be maintained by the nail, static locking must be carried out. If locking is purely to ensure correct rotation of the tibia, dynamic locking is appropriate. Static locking will be shown first. The tissue protector with the inserted trocar is passed through the hole marked STAT on the insertion handle and down onto the bone. The trocar is removed and is replaced by the 3.2 mm drill sleeve. We drill a 3.2 mm hole through both cortices. We measure the required length of the bolt through the tissue protector. To ensure that the self-cutting trocar tips of the locking bolt penetrate the far cortex, we need to add 2 mm to the length. After insertion of the locking bolt, the tissue protector is removed. The procedure is the same for insertion of the dynamic locking bolt. In addition to the two proximal locking bolts in the coronal plane, an additional diagonal locking bolt can be inserted. The cross-section of the proximal tibia shows the obvious advantage of this screw arrangement. Due to the ventral position of the intramedullary nail, here shown in black, the medial lateral locking bolt is not firmly anchored in the thin cortical bone. Locking bolts to be inserted diagonally are longer and have a better purchase in cancellous bone. A combination of medial-lateral and diagonal locking leads to better fixation of the proximal fragment in proximal tibia fractures. The 45-degree insertion handle is used to position the diagonal bolt. This handle may be positioned medially or laterally, according to the desired position of the bolt. The 45-degree insertion handle is held in the correct position by a knurled nut. Actual insertion of the locking bolt is carried out in relation to the medial-lateral bolt. Once locking has been completed, the 45-degree insertion handle and the insertion assembly are removed. This section illustrates the position and orientation of the proximal locking bolt. The sealing screw prevents tissue ingrowth into the proximal end of the nail and facilitates explantation after successful healing of the fracture. Removal of the unreamed tibial nail. Having removed the locking bolts, the coupling block marked extraction is placed on the proximal end of the nail and fixed with the connecting screw. The inserter extractor is positioned and the nail removed by gentle blows of the slotted hammer.